In this video, we'll look at the graphs of the other trig functions. 4.5, we covered the graphs of sine and cosine. And again, those are important, everybody. You're going to notice as we go through this video, tangent, like we've seen in several other places, just with the facts. Yes, it's based on sine and cosine, but it comes up often enough that we kind of need it as its own special case. But then for secant and cosecant, it's all going to be about graphing the appropriate sine and cosine function. So if you thought the last video you could have used a little more practice with sine and cosine, you're going to get it in this video. And the last reminder is to remember these are the types of questions we should expect. If there's graph questions on any quiz or test that comes from chapter 4, we should expect that it's going to be the other trig functions. So let's start with tangent, like we said. Let's start thinking about the graph y equals tan x. I'm still going to go back to that unit circle, everyone. And this is going to be a bit of a pain because I'm already using y and x here as my variables, and that x and y mean completely different things over here. But overall, this is really just to get the basic sketch out. So if you get a little confused, this is ultimately what we need. I'm still going to give directions like I did in the other video, where all these functions will continue forever. They'll just be these repeated cycles over and over again. So let's have everything important labeled for one cycle, and then we'll just draw at least a part of a second cycle to show that it continues. So back to my unit circle, standard angle theta, and xy pair, where x represents cosine and y represents sine. But we care about tangent. Well, we know tangent is sine over cosine, which in this setup boils down to the y coordinate for sine over the x coordinate for cosine. So I'm literally thinking about what happens when I do y divided by x as I go around my circle. So again, x is really my angle, and y will be the ratio y over x. So right off the bat, right here, what happens when I do y divided by x? Well, I get 0 divided by 1 is 0. So tangent also has a point on the origin. Very nice. But now what happens as I move through the first quadrant? Well, the y values get bigger. That by itself, when the numerator gets bigger, gets the whole fraction bigger. Just think practically, everyone. 4 over 2 compared to 6 over 2 compared to 10 over 2 compared to 18 over 2. Bigger numerator makes for a bigger total value. So y gets bigger, making the fraction bigger. But what about x? X gets smaller. And that by itself also makes the fraction bigger. 1 over 1/2 is 2. 1 over 1/3 is 3. 1 over 1/5 is 5. 1 over 1/10 is 10. So both of those, y is getting bigger, x is getting smaller, makes the whole function get bigger until I get to here at 90 degrees. And at 90 degrees, I get 1 divided by 0. A k divided by 0 gives me an asymptote. So this is getting bigger, and it's approaching positive infinity as I approach that asymptote. But now as I keep going, well, as we've seen a lot, if you finish on this side of the vertical asymptote, is a good chance you're going to start down here. But literally, as soon as I cross, now the x's become negative. So I'm getting huge negative fractions moving along to here. And when I do y divided by x, I'm back to 0. So at 180, I'm back to 0. And this is the last funny thing about tangent. What happens as I go past here? I already repeat what we had. As I get closer to 270, I get another vertical asymptote like this. And this piece is already repeating what we had here. And then if you kept going to 360, you'd be right to here. So this continues forever in this direction, but that it also happens over here. So again, get one of these repeating curves. It still repeats forever, so we're still going to talk about the period, but here's the biggest difference. Sine and cosine, nothing repeated until you did one loop around the unit circle. So it took the whole 360 degrees. Here, we repeated after we got halfway through. So the original period for tangent will only be 180 degrees. Or again, pi. Pi is 180 if you're using your radians. So we'll still have the whole idea, tangent of kx. That k will influence the period, and we'll do the original period divided by k to give us the new period. So that is still similar. We've got a very different look to the graph, but we still have the idea of period, and we still have the k as the multiplier inside, original period divided by k to get our new period. But come back over here, and let's just realize the idea of amplitude doesn't make any sense here. Amplitude was all about that idea of distance to the high and low values. Well, this goes up forever. This goes down forever. This goes up forever. This goes down forever. We're going up to infinity, down to negative infinity. There are no highs and lows. It goes forever up, forever down. So the idea of amplitude is basically out the window here. So we won't ask about amplitude. That doesn't even make any sense. The last thing to realize, when I drew this graph, I said one cycle was this to here. That was one cycle of the curve. But that's a little awkward, everyone. Don't we realize that having that vertical asymptote in the middle makes it a little awkward to focus on that as one cycle? So when we look at one cycle, most people tend to go the other way. Don't start here. Look at this as one cycle. And again, look at the symmetry. Tangent also is an odd function with this nice symmetry. Negative 90 on the left side, positive 90 on the right side. That totals 180 degrees. That gives me the original period. So for most of us, when we draw one cycle, we'll draw this cycle and we'll keep this labeled. We don't even need the y's anymore. We just need to keep track of the x's, and then it can draw extra cycles here or here, but this is where we'll keep everything labeled. So let's jump right in. Let's sketch, and same directions. I won't write it out, but just like the other one. Let's sketch, let's label everything for one cycle, and sketch at least 2 total cycles. And let's sketch y equals negative tangent of 5x. Well, the negative, there's my reflection across the x-axis. Think how that works. Well, instead of starting here and going up and this goes down, it would be the reverse. I would have this would be the one cycle of negative tangent. There the k is 5. So for the new period, I'll do 180 divided by 5, which will give me 36. Again, I control the scale, everybody. So I'm basically just going to draw the same picture, but just have the reflection. And if it's 36 degrees from here to here, well, that would be negative 18 on the left side and positive 18 on the right. That's one full cycle. That's everything labeled. And now again, just to get another cycle to show it doesn't just start and stop here and here. That maybe either continue this way, or again, you've got another one over here this way, just to show it's not just the one cycle. That's it. That's tangent. Well, cotangent, we do a little bit of a flip here. Just the whole idea, cotangent is 1 over tangent. So we'll kind of see that idea of 1 over, and we'll focus on cosecant and secant. But you could also do the same thing with cotangent, focusing on tangent. So let's jump right into the next two. Let's focus. And now I don't need the unit circle on everybody. Now for the next two, if I focus on graphing y equals cosecant x and y equals secant x. Well, to realize cosecant, is 1 over sine, and secant is 1 over cosine. That is really the one fact we've always said that we need to know about the reciprocal trig functions, how they get back to the appropriate sine and cosine. So how do you graph a 1 over? Well, the first thing is you graph the original. If I graph sine, and again, I'm drawing bunches of cycles, there's my original sine function with a high of 1 and a low of -1. Well, let's focus on a few things. What happens at the peaks and the valleys when you do 1 over this? Well, 1 over +1 is still +1. And 1 over -1 is still -1. So these points, the extreme highs and lows that we identified on the sine, and we'll see in a moment on the cosine, will still be highs and lows on the new graph. But it's everything else. Because the original sine curve went from -1 to +1, when you do 1 over those, well, we get a lot of 1 over zeros. 1 over zeros leads to vertical asymptotes. So every place where we originally cross the x-axis, or if we start shifting up and down, where we cross our midline, that'll become a vertical asymptote. And now, this point that went along with the high value on sine becomes the low value on cosecant, and the actual graph is this U shape inside these two asymptotes. And then I continue, but now I do the opposite. What used to be the low value on sine becomes the high value on cosecant, and now I get an upside down U between these two. And then an open U on this, then an upside down U here, then an open U here. So again, all I need to do is draw the graph of sine, still keep my highs and lows, get these new asymptotes drawn in where we cross the midline, and then these, they almost look like parabolas, but just the thing is, everybody, a parabola keeps going up and away, down and away. These have to fit inside your vertical asymptotes. And everything else is identical, everyone. If this was the plain sine graph, this was 90, 180, 270, 360, and those values are still the same important x values for the cosecant. Same idea happens with cosine and secant. Here is my original cosine graph with multiple cycles. So these would be the peaks, these would be the valleys, where I cross the x-axis will be the vertical asymptotes, open U, downward U, open U, downward U, and these would be the graph for secant. So what I will suggest, we'll do this in just a moment. We'll do a couple of examples, and that'll wrap up this section. And I'll definitely try and push us a little bit, because it doesn't matter how ugly the graphs look. It's all about graphing the appropriate sine and cosine and then doing this work. So the last thing I'll just say before we actually start doing it ourselves is just to realize you don't want to leave all this on your graph at the end. So some people, I wanted to show you all of this, but again, these pieces were the graph for cosecant. These pieces were the graph for secant. So that's what we want to focus on. So two possibilities. Either we do our first part in pencil and then go back and erase it, or we just do this lightly, or maybe in dash lines, or we come back and just circle and highlight what you want to show as the final piece. So a couple of different options, but just at the end, don't leave me this. Make it clear, this is what you want to highlight as your graph. Or up here, this is what you want to highlight. So let's sketch. Same directions we keep doing. 2 cycles, at least 2 cycles. Label all key points for 1 cycle. And let's start off looking at number 1. Let's look at y equals negative 5 secant x minus 10. Looks like quite a bit, but all I have to realize, technically this is minus 5 times 1 over cosine x minus 10, but I don't have to worry about that. Just consider graphing minus 5 cosine x minus 10. My amplitude is 5. I should have mentioned this in the previous video. We never say an amplitude is negative. The idea of amplitude always has distance. So just the numerical part gives me the amplitude. The negative is the reflection across the x-axis. I've got a 1 in front of the x, so my period is the original 360 divided by 1. So that hasn't changed, it's still 360. This minus 10 on the inside pushes everything right 10 units. So, all of that. How do I sketch all of that? Well, I'm going to come right over here. Actually, I'm going to do the cosine here, and then I'll come back and do it again. So just focusing on the cosine part. Amplitude is 5. I'm going to start at the bottom because I've got the reflection. So here's the upside down. There's 1 cycle of cosine. Again, can keep going for more cycles. Okay, the high is 5. The low is negative 5. But now I need to shift everything right 10. So this is no longer the y-axis. Either I could redraw the y-axis or just start off by labeling that as x is 10. Well, if this is x is 10, then this is no longer 360 by the time I repeat, it's 370. And when I think of my increment, 360 divided by 4 is 90. Well, I started at 10. Plus 90, that gets me to 100. Plus 90, 190. Plus 90, that'll be 280. And one more 90, I completed the whole circle. So a couple options. I left the original y-axis in place, but maybe right off the bat, I already noted the reflection when I started graphing, and maybe I already wanted the right 10, so I start graphing over here. But either way, that's my good cosine, so now I can think about the flipping part, and that would involve vertical asymptotes there. This point is a bottom. I would get my half U down, a peak, I get my full U above. This would just finish the 1 cycle, but then it keep going to show more cycles, the full U below, the full U above, and again, that's your final answer. So there was a lot that just happened there, everybody. So let's do that again. I did not pick an easy one. I kind of jumped right in. I didn't pick an easy secant. I already pushed you hard to draw a hard cosine, and then just get used to the flipping. So one more time. That right off the bat, I noted all these facts. So I knew I had my negative 5, my positive 5. I started right 10. So this is my regular cosine, but I'm going to draw this very light. So now as I draw that lightly, and now I can get my asymptotes drawn in, and now I can go right for the main graph. So what does the secant curve look like? Starting at this valley and the half U down. The other half would be over here if you want to draw it. This peak, this U opens up, and then right here, this would be another half U if you want to draw the other one, and there's everything. Oh, I'm sorry. I should have got my important x's before I finish that. Starting at 10, so going 90 is 100, another 90, 190, another 90, 280, and one more 90, 370. Maybe a little tight here. I could have had a little more space, but in the end, that's my graph. Here, here, here. That's one full cycle, and I'm showing more. You want to show even more still? That's fine. Over here. I could always keep adding more sections, and ultimately, that is the graph of secant. Okay, let's do one more. Let's look at y equals 4 cosecant Let's do 2x, and let's do a plus 3 on the outside. Same directions. We're going to sketch this, all that same stuff I kept saying. Sketch at least 2 cycles, label all the key points for 1 cycle. And if I'm going to sketch this one, well, I'm really going to start sketching for sine 2x plus 3. So the amplitude is 4, no extra negative, no reflection here, no extra addition, subtraction on the inside, but I do have a k. So my new period, the original divided by k, gives me the new, and that plus 3 pushes everything up 3. So some people just the 4, the negative 4. There's their sine graph, but now this is only 180, so I get 45 degrees for my interval. But now everything has to go up 3, and this is just what I was showing on the other one. Now my y scale is going to change a little bit, so I could still leave this, but then just relabel everything. Everything went up 3. So 4 is no longer the high value. Everything goes up 3. That's now 7. The x-axis is no longer in the middle. This would now be y equals 3, got pushed up 3. The low values would no longer be negative 4. It went up 3, it's negative 1. I mean, we're used to seeing the x-axis. That's why this feels weird, but that would be correct. But a lot of us, and I'm going to come back, I still need to do the flip part for cosecant. So it's just a little bit about how to handle that up-down. Similarly, how I took an extra moment talking about how to handle that right 10. Either to just realize it's there, so leave it as the y-axis, but then just start as 10, and then make your scale, or to literally do that right off the bat. But either way, you need to somehow make it clear that the beginning of this graph was starting here at that 10. Oops. Sorry about that. That was a little goofed here. This was that initial key point, not here, here. So that was the half loop right here, and then the other half if you wanted to show some more. Okay, so but back to the one we were working on. So this one right here, redoing my scale, or the original negative 4 to 4, and then draw it again. But now we think about it a little bit and say, oh, okay, well now it's negative 1, 3, and 7. There's your sine curve with that as the midline. 45. Again, not here, it's here. That's the 90. 135. And not here, but here. The midline, there's the 180. So there's good for sine. And now when I really try and get this back to cosecant, right from here, where I cross the x-axis, well, I'm sorry, where I cross the midline, it's no longer the x-axis. There are the vertical asymptotes. This peak becomes the bottom of an upward U inside here. This valley becomes the top of an upside down U. There's one full cycle of cosecant. And as we always say, be sure to at least show a little more. That would be enough. Can include some over here. Again, or it can just start all over. I mean, some people, once they get the framework set up, they're good enough that they don't even have to draw a sign. They could just jump to the flips, getting the vertical asymptotes where appropriate, and getting the U's, the upside down and the open face U's to match up. This was a peak above, so this opens above. This was below, so it opens below.